A virtual network, or VNet, is the foundation of your private network in Microsoft Azure. It's where your cloud resources communicate securely with each other, with the internet, and with your on-prem environment, all within boundaries that you define. When you create a virtual network, the first step is to assign a private address space for the network. For example, you might designate 10.0.0.0/16 as the address space for your network. That range becomes your virtual network's footprint inside Azure. From there, you divide that address space into subnets, which let you organize and isolate resources like VMs, databases, and application tiers. Each subnet can have its own routing rules and security settings, giving you fine-grained control over how traffic flows within your environment. Each network-enabled resource connects to the virtual network through a network interface, or NIC. The NIC receives an IP address from the subnet, and if needed, it also gets a public IP for internet connectivity. It's important to note that by default, resources in the same virtual network can communicate privately with one another without going through the internet. And speaking of connectivity, Azure Virtual Networks are highly flexible. For example, you can connect two networks together using virtual network peering, which allows seamless communication between them, even across regions. And when you do this, those peered networks use Microsoft's private backbone network rather than the public internet, resulting in lower latency and improved security. Now, if you need to connect your Azure environment to on-prem infrastructure, you can use a VPN Gateway or Azure ExpressRoute. A VPN Gateway creates encrypted tunnels over the internet, while ExpressRoute provides a dedicated private connection through an approved network provider. This gives you options based on performance, security, and compliance needs. I should note that routing within a virtual network is mostly automatic because Azure creates system routes that direct traffic inside the network and to the internet when appropriate. However, you can customize this routing with user-defined routes, or UDRs, to send traffic through a firewall, or maybe a network virtual appliance, or a NAT gateway if you need more control. Security is another key aspect of VNet design. To address this, Azure provides network security groups, or NSGs, which you can attach to subnets or individual NICs to filter inbound and outbound traffic. Each NSG contains rules that allow or deny traffic based on IP, port, and protocol. To add another layer of protection for platform services, you can use Private Endpoints. What Private Endpoints do is assign services like Azure Storage or SQL database a private IP address inside your virtual network, ensuring that communication never leaves the Azure network. Before you go running out and deploying a VNet, it's worth keeping a few best practices in mind. For example, avoid overlapping address spaces if you plan to connect multiple VNets or if you're planning on building hybrid networks. You should also use subnet segmentation to separate workloads. For example, front-end, application, and database tiers, so you can apply different levels of control and monitoring. If you need to connect VNets in the same region, use peering instead of VPNs since it's faster and more cost-effective. And lastly, always monitor routes and traffic paths so you know exactly how data moves across your network. In short, an Azure Virtual Network is a private, configurable network in the cloud. It gives you control over addressing, routing, and security, all built on Microsoft's global infrastructure. As you'd expect, understanding VNets is an essential step toward building secure, scalable architectures in Azure.